Hey guys, today we're doing section 10 in advanced algebra for chapter 9, which is on using logarithms to solve exponential equations. So we've been learning about logarithms and exponential equations for this whole chapter, and now we're going to kind of wrap it up and we're going to talk about the main reason that we need logarithms in the first place, and that is in order to solve our exponential equations. So our steps in solving these exponential equations using logarithms are to start by taking the log of both sides, and of course that's after you've simplified everything, and apply the power property of logarithms and then solve the resulting linear equation. So let's just go through a couple problems and follow these steps. The first one, I've got 5 to the x equals 20. So I'm going to start by taking the log of both sides. So I've got the log of 5 to the x equals the log of 20. Then I can use my power property to move this x down to the front. So I go x times the log of 5 equals the log of 20. Well, if I'm trying to get x by itself, I can divide both sides by the log of 5. So now I've got x equals the log of 20 divided by the log of 5. I can just type that into my calculator. Make sure you close your parentheses when you do that. And when I do that, I get x equals 1.861. Okay, I can do the same thing over here. I've got 16 to the x equals 18. So if I take the log of both sides, that's log of 16 to the x equals log of 8. Then I can move my x down to the front, and I get x times the log of 16 equals the log of 8. Then I can divide both sides by the log of 16. And when I do that, I get x equals the log of 8 over the log of 16. And when I type that into my calculator, I get x equals 0.75. I can do the same thing over here. So I start by taking the log of both sides. So I've got the log of 12 to the x plus 5 equals log of 17. Again, I can move that exponent down to the front. So I have x plus 5 times the log of 12 equals the log of 17. Then I can divide both sides by the log of 12. So now I've got x plus 5 equals the log of 17 over the log of 12. And I can subtract 5 from that to get rid of that 5. And when I type that into my calculator, I get negative 3.8598. Okay, so one of the main types of problems that we want to solve using these logarithms is our compound interest formulas using our continuously compounded formula. So that's our PERT formula. So we want to know how long would it take to deposit a deposit paying 5.8% interest compounded continuously to double. So remember that that's our PERT formula, A equals PE to the RT. So if I want to figure out how long it takes this to double, I can say that my principal is 1 and the amount I get out is 2. I know that my interest rate is 5.8%, so I'm going to write that as 0.058. And I want to solve for t, so I'm trying to figure out what is t. So when I plug all that stuff in, I get 2 equals 1e to the 0.058t. So naturally, I can solve this using my logarithms. So I'm going to start by taking the log of both sides, and I'm going to take the natural log of both sides because this has a base of e. So I'll have the natural log of 2 equals the natural log of e to the 0.058t. When I take that natural log, I can move that exponent down into the front, and I get 0.058t times the natural log of e equals the natural log of 2. Now the natural log of e, if I think about that, if I have the natural log of e, that's e to the something equals e. Well, that's obviously just going to be 1 because e to the first power equals e, so that just cancels out. So then I can divide this by 0.058, and I do that to both sides. So in my calculator, I'm going to plug in the natural log of 2 divided by 0.058, and that is going to give me 11.95. So that means it takes approximately 12 years to double. Next up, we've got the change of base property. So the change of base property is what we use when we have some sort of base that's not 10 and it's not e. Because our calculator can do 10 and e, but it can't do any other bases. So we can use this change of base formula to change the base into something like 10 or e that we can actually use on our calculator. So it says that the log base b of a is equal to the log of a over the log of b. So notice that it's changed into a common logarithm here, and all we've done is we've used this b value on the bottom and the a value on the top. So if I want to go through and do a couple of these, here I've got log base 4 of 100. So using the change of base formula, this is my a value, this is my b value. I can say that's the same thing as the log of 100 over the log of 4. And you can just type that into your calculator and you get 3.3219. Next up, we've got log base 3 of 45. So again, this is your a value, this is your b value. So I've got log of 45 over log of 3. If I type that into my calculator, I get 3.465. And next up, I've got log base 7 of 9,000. This is my a value, this is my b value. So this gives me log of 9,000 over log of 7. If I type that into my calculator, I get 4.679. And that's everything for section 10.